Okay, so we're continuing on from question 4. Question 4 part A is a probability question, right? So there's this guy called Huang, and he has to answer 5 multiple choice questions, right? Each question has 4 answers, and he's going to choose all of them randomly. Okay, so part A is asking me what is the probability that Huang selects 3 correct answers and 2 incorrect, right? So what's the probability of this? So to get the probability out, the chance of me getting a correct answer independently is 1 in 4, right? But because I need to get 3 of them out, I'm going to be multiplying, well, taking that to the power of 3. And I need to be getting 2 incorrect answers, so it's going to be 3 on 4 to the power of 2, right? So the chance of me getting a question wrong is 3 on 4. But now remember that it doesn't matter which order that I get. It doesn't matter if I get 3 correct first or 3 correct last, or in fact if I get every odd question correct, right? As long as I get 3 correct. So in order to deal with the order, right? In order to deal with the order, I need to go 5 choose 3. Right, so the answer is 5 choose 3, and then a quarter to the power of 3, 3 quarters to the power of 2. Okay, so I hope that made sense. Part 2. So part 2 is asking what is the probability that one selects 3 or more. So 3 or more correct answers. So it's got to be 3 correct, 4 correct, or 5 correct. Now notice how I said or. Now with these things, they're independent events, right? They're exclusive. So getting 3 correct is not the same as getting the 4th one correct. So, and it's definitely not the same as getting 5 correct. So basically what we're going to do is we're going to do this. So getting 3 correct, we did it up here. So I'm just going to write that down. 5 choose 3, quarter to the power of 3, 3 quarters to the power of 2. Now what I'm going to do is I'm going to add. Whenever they're mutually exclusive, what you have to do is you have to add the probabilities up. So the next one I'll be doing 5 choose 4. It will be 1 on 4 to the power of 4, 3 on 4 to the power of 1, right? And then the last one is going to be 5 choose 5. Now you should know that 5 choose 5 is simply 1, right? So I didn't really need to bother writing that, but anyway, I'm just going to write it anyway. And it will be 1 on 4 to the power of 5, and then 3 quarters to the power of 0, which is 1, right? So I'm not going to bother writing that one down. Okay, part 3. So part 3 is asking us what is the probability that one selects at least 1 incorrect answer. So it's got to be at least 1 incorrect. Now I can do the same as what I did up here and go 1 incorrect, 2 incorrect, 3 incorrect, 4 and 5, or what I can do is go so 1 incorrect, 2 and so on, or I can go if you remember your probability rules, it's simply a matter of going so let me scroll this down. It's simply a matter of going 1 minus getting all of them correct, right? So just think about it. The probability of me getting either 1, 2, 3, 4 or 5 incorrect is the same as me going 1 minus the chance of me getting all of them correct. So it's going to be 1 minus 1 on 4 to the power of 5. Okay, I didn't need to write this part down. Okay, so that's the probability part done. Let's keep going. Right. So part B of this question. Part B has given me this function f of x is equal to x to the 4 plus 3x squared all on x to the 4 plus 3. So that's 4. Okay, now what it's asking me to do is, well, first of all, show that this is an even function. So part 1 is saying show that this is an even function. Any even or odd question, what you need to start off by doing is say, what is f of minus x? That's the question you should be asking yourself. What is f of minus x? So I'll substitute this one in. So it's going to be minus x all to the power of 4. Now remember, it's all to the power of 4. That's the key word over here. And then it's going to be 3 minus x all to the power of 2. And when I say all, I mean the minus x, right? And then same thing at the bottom, so it'll be minus x to the power of 4 plus 3. And because these are all even powers, it doesn't matter if it's a negative or a positive, right? So I can simply write this as x to the 4 plus 3x squared all on x to the 4 plus 3. And guess what? This is the same as my f of x, right? So therefore I can say it's even because f of minus x over here is equal to f of x. Okay, all right, so part 2. So part 2 of the question is asking me what is the horizontal asymptote? So I'm running out of room here, but I'll answer that one quickly. The horizontal asymptote in this case is simply going to be 1, y equals 1, because if you think about it, when x goes to infinity, right? So when x goes to infinity, I'll write this equation again. So I have x to the 4 on x to the 4 plus 3, right? Plus 3x squared on x to the 4 plus 3. So if you look at this, this has two separate things, right? I just broken up the fraction. When x goes to infinity, right? This plus 3 over here doesn't really matter, because basically what I have is infinity to the power of 4 on infinity to the power of 4, and they're pretty much the same numbers. So this thing over here, this fraction over here is going to be equal to 1. This, on the other hand, I have an infinity squared divided by infinity to the power of 4. The bottom is going to rise much faster than x squared. Okay, so because of that, this part over here is going to go to 0. So in the end, I end up with y equals 1 as being my horizontal asymptote. Okay, part C. So part C is asking me to find what is the stationary points of that function. So rewriting it again, I have x to the 4 plus 3x squared all on x to the 4 plus 3, right? It's asking me to find the stationary points of this problem. Okay, so any stationary point question, what do? You find the you differentiate, right? Now before you jump in and differentiate, I'm actually going to do a small thing which actually makes it slightly easier for you to analyze. So I'm going to write this. The top I can write as x to the 4 plus 3 on x to the 4 plus 3. You know, obviously you're thinking, hey, where did this 3 come from? I introduced that 3, so that's a key thing. I introduced that thing, and then the next bit I'm going to write plus 3x squared on x to the 4 plus 3. But because I introduced this 3, I need to get rid of it, so I'm going to say minus 3 over here. And guess what? This part over here is 1, right? And because it's 1, when we differentiate it, it disappears, right? So that's a tiny little advantage that we have when we're doing this problem. So I'm differentiating this function. Okay, so I'm looking at this function as opposed to the original one. So f dash x is going to be equal to, so this part is going to disappear, become 0 because it's just 1, right? And this part over here, you need to remember your quotient rule, but it goes like this. So the bottom is going to get squared, right? And the top over here, so what you do is you write exactly what you wrote over here, right, without changing it, and then we multiply it by the top differentiated. So the top differentiated is going to be 6x, right, minus, because I differentiated the top, I leave it alone, so it's going to be 3x squared minus 3 times the bottom differentiated. So the bottom differentiated, oh, I gotta squeeze this one in, so forgive me for doing this, but it's going to be 4x cubed. Okay, so it's got to go down there. All right. So now I'm going to expand my brackets, right? And when I expand my brackets, I will end up getting 6x to the 5 plus 18x minus 12x to the 5 plus 12x cubed, all on whatever the bottom thing is, squared. Now in an exam, if you're really running out of time, you can do the dot dot dot. I really don't think they will mind, but it's safe not to. So anyway, I'll let you decide what you want to do. And at the top, what I can do is I can take 6x out as a factor, right? And then collecting all the like terms. So for example, I mean, I mean this guy and this guy, right? When I collect the terms, inside I will end up with minus x to the 4 plus 2x squared plus 3. Now if this isn't too obvious for you, you can look at this thing inside the bracket as a quadratic, right? Except this time it's in terms of x squared as opposed to x, right? So I managed to factorize this, and it looks a bit like this. So it goes minus x squared plus 3, and the second bracket is going to be x squared plus 1 dot 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 is equal to 0 for stationary points, right? And you should write 4 stationary points. I just can't because I don't have room over here. So solving this one, this bit over here, x squared plus 1 cannot be equal to 0, right? Because I will end up getting x squared is equal to minus 1, and that's not a solution, right? So if you're doing 4 unit maths or something like that, you'll realize you can get a solution. But as far as 3 unit goes, don't worry about it. So the solutions are going to be x is equal to 0, or x is equal to plus or minus square root of 3. Right, so those are your solutions. So that's where your stationary points are going to happen. Okay, find all stationary points for the graph. Now, because they're asking you for stationary points, what you really need to do is you need to substitute this back into the function. So y is equal to f of x, right? So at x equals 0, so f of 0 is equal to, I'll end up getting 0 on 3, which is equal to 0. F of and remember, because I said it was an even function, I don't really need to do the minus 1 separately, because it's going to be the same as positive 1. So the plus or minus root 3, it's going to end up being so 3 square root of 3 to the power of 4 is the same as 3 squared, right? So let me say that again. Square root of 3 to the power of 4, same as 3 squared, which is 9, right? And then 3, so this will be 3 times 3, which is 9 again, all on 9 plus 3. So I will end up with 18 on 12, or rather 3 on 2. Okay, all right. So the very last part of this question is asking me to plot this. Okay, so let me draw my axes. So a bit wobbly, but anyway. Okay, so I know that there is a horizontal asymptote, right, at y equals 1. I know that it's going to go through 0, and I know that it has a stationary point at x equals negative root 3 and root 3. Okay, so what is this graph going to look like? So it's just a matter of joining out the dots, really. So it's going to go up like that. It's going to go out to the left like that as well. And so because remember it's symmetric, and because it's the asymptote, it's going to end up approaching 1. So there you go. So that's what my graph looks like. All right, so y and x. Okay, so that's it for question 4. If you have any questions or comments, let me know. But thanks for listening.